Hello. Now we begin to consider the first one.
Present 老师
OK，6210 ，Hello， 6210 ，Hello this boy，
Present 老师
OK， 51222
Present 老师
，Next 任北，we're not here. Next 6211.
Present 老师
Okay, next 1 to 18.
Yes, 18.
Okay. Next 1 to 08.
Present Miss.
Pasimo 1 to 14. Okay. 1 to 13. 13.
Present teacher. Present
13.
teacher.
Okay.
Present teacher.
1 to 09. Hello, 1 to 09. Over here, Sabeter 11.
Oh, present.
6207. Hello, 6207. One two two zero. 1220.
I'm present, miss.
1207.
I'm here, miss.
ITER 6206.
I'm present, miss.
1206.
I'm here, teacher.
1 to 10. Oh,
I'm here, teacher. I'm here.
okay. 1204.
Present teacher. I'm here.
Okay. Sajibu 1205.
Present 老师
Okay, 1203. Famin 1203. Famin 6 to 12. This one.
I'm present. I'm present.
Okay. Next, Ocean 6205. Oh. 6205. 欧书文，来，
到老师。
Next, 1201. 120. Oh, this is Amos. Okay, here. 1 to 16.
Present, Miss.
1 to 15.
I'm here, Miss.
I mean, you should wait for a while, in a minute, for a second time. Okay. 15.
I'm here, Miss.
Okay. 1202. 6203.
到老师
6204.
I'm here, teacher.
6208. 6208. 61201. Hello, 120. 6209.
Present, Leoshi.
Twelve.
Present teacher. Present teacher.
Okay, Jilang is not here. Is here. Okay, for a second time. Bay. 1 to 19. One to 19. 1209. Hello, 1209. Hello. Okay, this one. 6207. 6207. What? What I mean? Okay, I know. I see your message.
I'm here, present teacher.
Okay. Oh, sure. If your net is where, maybe you can send your message. Oh, sure. Why you?
Teacher,
Why? What?
teacher, I had a bad network. I am here. Studio
Oh,
5.
sure. Okay.
Thank you.
Next, 6208. Hello, 6208. Hello. Not here. Not here, I know. Oh, Jila, not here. Okay, we enter our call and begin our class. Who are making noise? Let me see who are making noise. Oh, this one, this boy. Mute him. First, we review the definitions we have learned last time. This is yesterday. Okay, we learned a lot. We have learned two important limits. Do you remember? We have learned two important limits. Do you remember it? First one, please tell me this one. X approaches 0, sin x over x. Please tell me. The limit is equal to. Hello, this one. The limit is equal to 1. Okay, this is the first important limit. And we have learned the second one. The second is 1 minus cos x over x. Please tell me this limit is equal to 1. No, the second one. Here, this one, the limit is equal to 0, right? 0 is equal to 0. And we have used these two important limits to calculate other limits, right? I hope you remember. And then we learned the limits of trigonometric functions. This means we can use substitution there. And then we learned here, this means we use important limit to calculate or to find this function's limit. And this is the special trigonometric limits. Okay, this theorem B are very important. And exam 2, we have done it one by one. And then we learned limits at infinity. This means we want to find the limit x approaches infinity, gx. Or we want to find the limit x approaches negative infinity, gx. This means limits at infinity. For this one, for example, here gx is x over 1 plus x squared. Do you remember we have a standard trick how to calculate this limits at infinity? We have a standard trick. We will it means we should find we should divide the highest power of numerator and the denominator. Right? Divide the power of x. Right? So this means we should divide by x squared or divided by x squared. Right? And we find the limit is 0. And we also learned the asymptote. Asymptote, A-S-Y-M-P-T-O, or asymptote. I'm wrong? Let me check. And we have learned the vertical asymptote and the horizontal asymptote. T-O-T. Sorry, it's the T-O-T. Yeah, square, okay? T-O-T. Do you remember vertical asymptote? How to find vertical asymptote and horizontal? Horizontal asymptote. First one, how to find the horizontal asymptote? Please tell me gx is x over 1 plus x squared. Please tell me this function is horizontal asymptote. Hello, this one, please tell me this function is horizontal asymptote. X over 1 plus x squared. This one, anyone knows? It's 2. No, it's wrong. Horizontal asymptote for gx over 1 plus x squared. Anyone knows horizontal asymptote? We learned it yesterday. This means the definition is we want to find x approaches infinity or limit x approaches negative infinity. Gx is b, gx or gx is b. We will light. This means y is b is a horizontal asymptote, right? So for the function x over 1 plus x squared, its horizontal asymptote is equal to, and this limit is equal to 0, right? So this means b is 0. This means y is 0 is horizontal asymptote, right? Okay, this means we know how to find horizontal asymptote and then to remember a vertical asymptote. How to find the vertical asymptote? Maybe I will introduce it later. Okay, review it later. Within the sequence, the limit of sequence, we use almost the same trick, standard trick, and then we learned infinite limits. This means we x approaches 2 from left. Here we see 1 over x minus g minus 2 is negative infinity. Here x approaches 2 from right. 1 over x minus 2 approaches infinity. So we find this curve is so we find x2, this is a vertical line. This is called a vertical asymptote, right? Now the definition. Here. Here we learned the definition of a vertical asymptote, right? A vertical asymptote, the line axis C of the graph of y's fx if any of the following four statements is true. So then we will find x approaches C from right, negative infinity or infinity, this is infinity, negative infinity. Then we will say axis C is a vertical asymptote, okay? Yeah, so for the function y is 1 over x minus 2, we find x is 2 is a vertical asymptote. Okay. The horizontal asymptote, we learned, we reviewed it before. And then we learn the continuity of functions. We use the word continuous. This means we have the definition of continuity at a point. We say that f is continuous at C if this means this limit is fc. We mean by this definition to require three things. This means limit exists, fc exists, and the limit is fc. If any one of these three fails, the f is discontinuous at C. And we have to theorize continuity of familiar functions. We have the continuity of polynomial and the rational functions. They are continuous at every real number C. This domain. And we have learned the absolute value function. The function is also continuous everywhere. Okay, everywhere. And we also have the nth functions, the continuity, the absolute value, and nth functions. And we have learned continuity under function operations. This means if f and g are continuous at C, these there are k times f plus g, f minus g, f times g, f over g. Provided that this is not zero, f comma n, f n third, provided f is 0 is greater than 0 if n is even. This function are all continuous. And we also have trigonometric functions are continuous at every real number C. Okay, for example, the sin x, cos x, and the tan x, cos x, sec x, and cosec x are continuous at every real number C in their domains. And we also learned the composite limit theorem. This means we have learned how to find the limit of a composition. And then we maybe last time before we end our class, this is the last time. This means we learned the continuity on an interval. Okay, we say an open interval is continuous. This means it is continuous at every point of that interval. Now we have the definition of continuity on a closed interval. So we have given the definition of right continuous, left continuous. Right continuous at A, this means the right limit is equal to FA. Left continuous, this means the left-hand limit is equal to FB. So we say F is continuous on an open interval. F is continuous at each point of that interval. F is continuous on a closed interval. F is continuous on this open interval. Right continuous at A, left continuous at B. Okay. And now, for example, it's correct to say that fx is 1 over x is continuous on open interval 0, 1, and gx is continuous on closed interval, because we know the square root x is continuous on this open interval. So we will take that is continuous, right continuous at 0, left continuous at 1. So right continuous. So this means operations 0 from right, fx change. So this is 0. This is 0, 0. So it's right continuous at so it's equal to 1. So this means the left continuous at point 1. Okay. Using the definition above, describe the continuity properties of a function whose graph is cast in figure 7. Okay. Describe the continuity properties of the interval of the function. This means you can describe on the interval infinity 0 to infinity, and I will write to 0 to 1. Interval 1, 3, and 3, 5, 5, infinity. This one. Consider 1, 2, 3, 4, 5. 5 intervals. Please consider if this function is continuous on this 5 intervals. Okay, from the graph. The first one, 0. Sorry. This is negative infinity to 0. Please hear me. This function is continuous or discontinuous. Discontinuous minus infinity to 0 is continuous or discontinuous. It's discontinuous. What? What? Continuous. Continuous. Yes, it's from the graph we know this is continuous. Go on without abrupt change, right? So it's continuous. This means it's continuous. Let me check it. Continuous. This is continuous, right? And 0, 1, 0, 1, continuous or discontinuous. Oh, I write open interval. Check it, open interval, 0, 1, 0, 1, continuous or discontinuous. Yeah, 0, this is 0, this is 1, on this interval, on this open interval, continuous or discontinuous. Discontinuous, 0, 1, are you sure? 1. Or from 0 to 1. But this 1 is not included. It's open interval. Or it's open. I just write this open interval. Continuous or discontinuous. Of course, no abrupt cease, right? So continuous, right? That's continuous. And from 1 to 3, 1 to 3, this close the interval. Please tell me, this close the interval. continuous or discontinuous? Yes, discontinuous, right? We can say at 3, there's a jump, right? A jump. So discontinuous. 3 and 5, let's close the interval. 3 to 5. The find is also discontinuous, right? And to 5 to infinity, this 5 is not included. So it's continuous, right? This is continuous, okay? Okay. Intuitively, for f to be continuous on AB means that the graph of f on AB should have no jumps, right? Go on without abrupt changes, have no jumps. So we should be able to draw the graph of f from the point A, FA, to the point B, FB, without lifting our pencil from the paper, right? Okay, thus the function f should take on every value between FA and FB. This property is stated more precisely in theorem F, in intermediate value theorem. Intermediate value theorem. This means let f be a function defined on AB and W. Here, W be a number between FA and FB. If f is continuous on AB, then there is at least one number C between A and B. This means one number C between A and B such that FC is equal to W. This means if it is continuous, we can draw the graph of f from the point A. For example, give you a graph. This is AFA. This is BFB. BFB. FA. This is FA. It's continuous. This means we can draw the graph of f from the point A, FA, to the point B, FB, without lifting our pencil from the paper. Thus, this means f can take on every value between A and B here. For example, this is W between FA and FB. And here, this means we can find number C such that FC is equal to W, right? So it's easy to understand. This is at least. Why is at least? Another graph. This is A, this is B. Here we can say, if this is W, this is FA, here FA, FB. So W is between FA and FB. So we find this is C1, right? This is a C2, this is C3, right? We have 3 points such that FC is W. So this means at least one number C between FA and FB, between A and B, such that FC is W in intermediate value theorem. Okay, and the finger here, this is finger 8. Finger 8 here. This is finger 8 shows that F is continuous at on AB. The intermediate value theorem says that for every W between FA and FB, there must be a C in AB such that FC is W. Here we can find this is W1 between FA and FB. We can find a C such that FC is W1. And this W2 between FA and FB. We can find the C1, C2, C3. At this point, F is W2. But if Here, in other words, F takes on every value between FA and FB. Continuity is needed here for this theorem. Continuity is needed for this theorem. For otherwise, it's possible to find the function f and the number w between FA and FB, such that there is no C in AB. Satisfies FC is W. Figure 9 shows an example of such a function. We can say fx is discontinuous on AB, right? There has a jump at maybe at this point. And here this is A, this is B. And W, of course, is between FA and FB. But we cannot find here, this is W. We cannot find a point C such that FC is W. The C does not exist. Right? From this, we can find so FC. So this means continuity is needed for theorem F. Okay, you should remember this condition. F must be continuous on AB. Right. This means in the intermediate value theorem can be used to tell us something about the solutions of equations. As examples, in page 87 of the textbook. Okay, you can see, you can read it. Okay, we have here we have exercise, not here. Okay, we have exercise for R from 1 to 4, 32 all of this. Okay. Maybe we can do 1 to 4 together. Okay. From 1 to 4, we do them together. But 32, 9, 15, 16, 29. This you should do it by yourself. Okay. This is exercise. And now we begin to do number 1. To say that x approaches infinity means that, you know, x approaches infinity. This means x, what? Means x, this means x gets larger and larger without bound, right? Without bound. So to say that the limit as x approaches infinity of f is L means that is what? Informal. Give your answer is in informal language. Okay, this is informal. This means you should understand this limit, right? What? Means that this you should think of it. This means x is equal to infinity. L is equal to infinity. No, this is L. This is a number. This is not infinity. Do you know this? This means if you understand this, you should reply. What? I know. Yeah, I know. This is just the answer. I want you to give me your answer. Why? just I want to hear from you. You tell me the answer. This means maybe you can write this means X gets larger and larger without bound. F is near L, right? Near L. Let me see. Oh, right. F gets close to L as X increases without bound. So this means the limit is L, right? Okay. And number two, to see like means what? Maybe you can say this one. From this one, maybe you will know how to write this. This means this just means this is right hand limit, right? This means Bx approaches C from right. Fx, this is infinity. So this means Fx, this means without increases without bound, right? It's infinity. So this means Fx increases without bound. Okay. To say that this is next to infinity. This means Vx approaches C from left, Fx decrease without bound, right? Decrease. Okay, third. Third. The line, which line? The line is what? 6 and 4. The line, what's line? What's the line? Okay, for this bracket, which the right. Hello, students online. Which line? Hello, students online. Are you listening to me? Oh, maybe they are not listening to me. They just in our meeting. The line, what's line? Okay. No, we are. Okay. Oh, if you are listening to me, please tell me your answer. Because I want to see, I want to know why the line y6 is it means horizontal, the right horizontal asymptote of the graph. Okay, number 4. X approaches 6 from right, this is infinity. In the line, not y. Yes, x equal to 6 is our vertical asymptote. Right. Yes. Okay. Okay, now to exercise for this one. 32, 9, 15, 16, 29. We just give you 8 minutes. I think it's enough. Now it's not clear. Okay. It's just the find limits. 20分钟 is too long. 8 minutes, I think is enough. Medium. Do you feel hot? Hot? I think it's very hot. Turn over this one. That one is okay.